Hello everyone, welcome back to alkaline hydroxide 784, and today in the mathematics series we are covering differential equations because, well, of course that's the last part of the calculus section. And yeah, let's get right into it because I think for me personally it is probably the hardest topic in calculus. So yeah, I do not know why. I mean, not harder as in the topic you're most likely to mess up. Let's put it that way. Yeah, the topic you're most likely to mess up in calculus is differential equations. Because there's just so many ways you can mess it up. Yeah, right. Okay, let's just start. So here there are 3 points. The first point is solving for differential equations in 3 different forms and all substitution in the sense. And the second point is formulating the differential equation based on a problem. And the third point is interpreting a differential equation and a solution in terms of a problem situation. So if you look at all of these 3 points, right, like it's, yeah, you realize that differential equations will definitely be tested along with some kind of problem question or something. Like you probably won't really see differential equation on its own. You're most likely to see it as part of a problem, unless the question asks you to do some substitution with in which then they'll probably just give you the differential equation to use a substitution. So yeah, that's how it's gonna be. And that's why it is very easy to mess up, because if you do not read the problem carefully and solve, like, write the correct differential equation, and like that's one area where you can mess up. So the second area where you can mess up is doing the actual converting the differential equation into what it originally was, which is by doing some kind of integration or by manipulating it algebraically. That's another place where you can mess up. And after doing all that stuff that where you can mess up, you may end up with an answer that's completely wrong and may not answer the question. So it is important to know all of these. It is important to know how to do it properly so that you don't mess up in these places, I guess. Yeah, so let's go to the actual things covered in the syllabus, let's say, per se. So the first place where you shouldn't mess up is how to solve differential equations to begin with. So let's go there. So there are 3 kinds of differential equations according to your learning objectives. The first one is dy over dx equals to fx, or some kind of expression in x, I guess. And y over dx equals to fy, the one you're most likely to encounter in your questions, because the first one is too easy, it's just integration. And the third one is also just double integration, which is d2y over dx squared equals to fx. The second one is the one which requires the most effort out of the 3, because you need to first you need to do something before you integrate, in the sense, and I'll tell you what that is soon in time to come. Okay, so for the first one, which is dy over dx equals to fx, it's very simple to just integrate it directly, which is by integration in general, like what we covered last time. Just use those techniques and integrate it. But of course, in terms of the question, um, usually you have a context. So this time, instead of giving c, you would probably have to give a constant. Yeah, so this is what you need to be aware of when you're doing differential equation questions, which is that constant c, or whatever other thing that you call it, in the sense. Because this time c isn't an arbitrary constant, but it's an actual number that you can derive from the question, I guess. And yeah, so for that you need to read the question carefully. So the first one is just integration. The third one, which is the d2y over dx squared equals to fx, as you can see, it is the second derivative of whatever answer that you need, and therefore you just need to do integration twice. and each time you will get a new constant. So for example, the first time you have a C, the second time you can put a D, and your let's say your so let's say you have d2y over dx squared is fx. So when you integrate it once, you get some expression plus c. Then you integrate it another time, you get an expression plus cx plus d. And yeah, just remember that's how it works. And you need to find out if you are given information, you need to find out what c and d are once again. So they're not just any arbitrary constant this time. You can say that if you do not know what C and D are yet, or if you haven't gone to the part where you solve it yet, you can just say that you can write the C and then say where C is a constant in real. But don't say arbitrary, because you know that it is a particular constant and not an arbitrary one. Yeah, just a minute detail that you need to take note of. Okay, so now let's go to the real stuff, which is dy over dx equals to fy. In this scenario, I like they usually teach you this method that where you can make it to make it into a dx, like to make it work. But for me, the way I like to do it the most is to just invert it. So instead of dy over dx equals to fy, make it dx over dy equals to 1 over fy. The reason why this works, well, it you shouldn't think of it like inverting fractions. This is a completely different thing, and there's a reason why it works. Let's just say that there's a reason why it works. So, like for example, if you have dy over dx is equal to I don't know, y squared plus 3y or something like that. I don't know. Actually, this plus 5 maybe, plus 5. So your dx, you can make it into dx or dy, which is equals to 1 over y squared plus 3y plus 5. Okay, if you were to think about it in a logical way, right, if you were to go from dy or dx and directly integrate both of them with regards to y instead, so if you have integrate dy dx with regards to dy, and this thing as well, integrate with regards to dy, um, you would you would end up with this scenario where your dy is, well, there's one here and there's one there, so it doesn't actually cancel out the thing in a way. mm. uh yeah, so actually I don't really know why it works. But it works. It is not wrong to show that, but you should understand that this is not because it doesn't work the same way as a fraction does. It works based on the rules of differentiation and integration. Yeah, maybe if I figure it out, I'll just write it down and show it to you. Yeah. uh yeah, so that's my way of doing it, because the way that they show confuses me, and yeah, just confuses me and makes it hard, like makes me make mistakes. So I'll just do it this way. But of course, when you do the 1 over whatever function that you get, like for example 1 over fy, you must be aware of the fact that you're doing 1 over fy. So whatever is in fy cannot be equal to 0 anymore. You must take note of that information when you're doing this. Like, oh, like you can kind of tell that you won't really be able to make it 0. And then you proceed on to integrate that with respect to y. And then, for example, if you have 1 over y squared plus 3y plus 5, you can make it, I don't know, 1 plus y plus 3 over 2 squared, because then you'll get y squared plus 3y plus 9 over 4, which is not 5, obviously. uh, then you put outside that whole thing squared, you put outside um, 11 over 4, of course. So I'm actually writing this down on a notebook first because, yeah, otherwise I'll just confuse myself. Okay, so then you can integrate this to get your answer. I think you know how to do that. Okay, cool. That's how you do the second one. So now for the final part of the first point, which is the substitution. Well, we already learned how to do substitution in the previous episode, so I assume you can do that. Just make sure you do the integration accordingly and be aware of the values that you need to input. Because, for example, if there's a value for y and x, there may be a different value for the substitution because the substitution is also a function of either y or x in this scenario. So once you do that, you will you'll be like if you don't take note of the values, you may end up making a mistake. And that's one more place where you can make a mistake, I guess. Haha. Yeah, so please be careful about that when you're doing differential equation. Yeah. Okay, so let's move on to the next part where you look at the question and you try to make a differential equation. Do I have to give an example here? Oh my gosh. Uh, okay, fine. So let's say you have your application of differentiation. It might be something kind of like that, but a different kind of scenario. But like instead of I don't know. Uh, oh yeah. So like the usual question, like the simplest way a question I can think of right now off the top of my head is the thing where they talk about the rate of population growth, for example. So let's say you have the population growth has a rate of this, and they give and that rate is like proportional to a certain value, for example. So let's say population growth is your thing that you want to find, so you call that P, and your rate is of course, okay, maybe not Ty, and your rate is dy or dx, and the yeah, so population number is y, the rate is dy or dx, and it says that the rate of population growth is equivalent to is directly proportional to half of the population or something like that. Let's say for example, then you would say that dy over dx is equal to well a gradient, a constant k times y over 2, because you say that it's proportional, right? So the k is your constant of proportionality. So in this scenario, instead of just c and d, now you have extra constants that are introduced by proportionality and things like that. And so when you have such constants, you need to be aware of them and try to find their values as well. So how do you do that? Uh, you can use the values given in the question because they'll probably tell at time this the population is this, or for example, let's say. So in our scenario, maybe let's say at time 0, the population is y is equal to 100 or something like that. Okay. Then your dy over dx is ky over 2, right? And you can make it into a dx or dy, 2 over ky, and then you integrate it, you will get x is equals to 2 over k ln y plus c, where c is your constant. So at t equals to 0, y is 100, let's say. Oh, sorry. Okay, let's just say x is t. Okay, t is x in this scenario. So in the actual question, write t, don't write x. Like dy or dt. Or dp or dt, depending on what constant you use. So, and for 0 would be equal to 2 over k ln 100 plus c. Yeah. And of course, from there you can try to find all your constants, and if you get two sets of values you can definitely find both of the constants without any issue whatsoever. And sometimes the constants may be hidden, like they may not really mention, oh, at this point of time this thing is this value. You may just say that, oh, like for example, if you are thinking of a car that's moving, let's say a stationary car moves from time t0 onwards. So at time t0 it actually has a velocity of 0 in a sense. So likewise there could be certain things that are unmentioned but actually but in reality they have a hidden value there that you can use in your calculation. So from calculating all of these things you can find out what are the uh, constants, and from there you can solve your equation without any issue. But of course when you use the method that I was talking about, which is doing the dx over dy, you still need to make y the subject of the equation eventually. So after you get your x and you find your two constants, do find out what y, like do make y the subject of the equation. So in this case, let's say if k is 10 and c is 5, so it say like x is 2 over 10 ln 100 plus 5. Of course 2 over 10 is 1 over 5, so yeah. So let's first minus 5, x minus 5, 1/5 ln 100, and then you times by 5 and then you undo the ln in the sense. So the final answer would then be, sorry, not ln 100, ln y. Okay, so the final answer would then be y is equals to e to the power of 5x minus 25. So using that you get your answer lah. Uh, yeah, of course if you have certain conditions that you need to take note of where in case of whether the constant is positive or negative or anything, you can then find out find out whether the constants are of a particular value or not. In case there are some cases where you don't get the constant immediately and then you coagulate all of the constant as a in front of the e, for example. Yeah. Yeah, so just make sure that in case there's certain restrictions, like for example e is, let's say y cannot be 0, for example, then e cannot be a certain value because y cannot be 0 in the sense. Yeah, so just take note of which values it cannot be and write it down if there are any values that it cannot be. Okay, cool. uh yeah, I think we kind of went through that. So now once you get the answer, right, how do you write it down in your question? That's the last point, which is interpreting the equation and its solution. I think it shouldn't be too hard, hopefully. If you understood the question, you should be able to do this interpretation fairly easily. Like for example, in our example, once you get your answer and you input a value for maybe x or y, let's say if you input a value for x, then your y is obviously the population at time whatever that number you put for x. And if you input a value of y, then you will find out that you'll find out what time you get this particular population number. Or if you're looking at dy or dx, you're looking at the rate of population growth or something like that. So just use that to figure out how to interpret your answer and just write it down, um, like just write down your interpretation as it is. Cool. So like for example, the question asks you, oh, what is the rate, like what is the population at time this? Then you must write down at time this is the population growth. Yeah, you shouldn't skimp on those words because that's pretty important for the differential equation question. Okay, so yeah, I think that's about it. We're done. So I hope you found this useful, I guess. If you have any questions or if you want me to actually talk about the way that the teacher teaches you how to do differential equations for the dy or dx equals to fy, then I will cover that. If not, if you have any doubts about why this thing works, I can try to cover that again. But if you don't have any questions, I think should be okay. Yeah, if you any question, just give it in the comments below or in Reddit. So if you enjoyed or found this video useful, please press the like button and subscribe. And with that, I would like to say thank you and bye.